So now we have a machine where Docker is already installed, right? Docker, you can see, yes, Docker is installed. Let me see, is there any Docker container or Docker image is already there or not? How to see all the containers running? Command is Docker ps, right? So ps says no container is running. And if I want to say all the containers, whether it's running or stop, the command is Docker ps-a, right? So there is a container, my prod container. Remember we have created last time, right? So this is the container ID. This is the image from it got created. Okay. And if I want to see the images also, Docker images. So yes, there is an image, that is an Alpine image. That is a tag, that is the image ID, and it's got created 3 weeks ago. But we took the class, our last session was last Saturday only, right? 1 week ago. Why it is showing 3 weeks ago? Because this is the time when the image got created. We have not created this image. We have downloaded this image from where we have downloaded? Anyone? Yes, Docker Hub, right? So we have downloaded this image from hub.docker.com, right? So this is hub.docker.com. Oops, don't show me, not now. hub.docker.com, right? So this is from where we have downloaded this image. Who maintains this Docker images? This hub.docker.com, Docker Incorporation. Okay, so Docker Incorporation is a company behind this. So just give me 1 minute, okay? So this is from where we have downloaded this image. This is an Alpine image, okay? This is an Alpine image. This is our image. This image is here, okay? So this image got created almost 3 weeks ago. Last updated 24 days. So that is why it's showing 3 weeks ago. Whenever you download an image, it will show you when it got created or modified or something, that whosoever the owner of that image. We are not the owner of this image. This image is basically maintained by Docker Incorporation, the company behind Docker. Okay. Now what we want to do, we want to create our own image from our own code. So what I will do, I will just I will make this delete everything. Okay, and we'll start from scratch, because we'll write our own code, and from there we'll write our Docker file and everything. Okay, so if you want to delete everything from your system, okay, there is a command, something known as Docker prune. Okay, prune, and Docker prune basically system, let me just remember the command, -- all if I'm not wrong. Docker prune -- all. Let me just try it. Docker system prune. Okay, Docker system prune -- all. Yeah, this one. Okay, so this is the command, Docker system prune. Okay, Docker system prune. Prune is basically you can prune your images, you can prune your container. I am saying prune everything. System prune all. Delete all my container, delete all my images from this particular machine. It will something like become a machine, brand new machine with Docker installed. But this command is little dangerous, because we are not going to delete our all container, all images from our running machine or production machine. This is a test bed, right? This is my test machine. I can play with it. So whenever you are running this command, make sure that where you are running this command. Okay, don't just run this command anywhere. Okay, so what it says, it will stop all your, delete all your stopped container, network images, everything, build cache and everything. So you can say, yes, I want to clean everything. So what it will do, it will just clean everything. Your system will become kind of a brand new machine. If you do Docker ps-a, you can say there is no stopped container. If you do Docker images, okay, you can see there is no image, everything got deleted. All right, so it got deleted everything. Now what we will do, we will create a container. I mean, we'll first create a code, then I'll show you how to write a Docker file, then how to create an image out of it. Everything will go step by step. All right, so for that let me create a directory here. All right, so what we will do, I'll say mkdir So mkdir, and I'll say my py app. This is a directory that I'm creating, okay, and after that we'll cd into that, cd to this. So right now I am inside a directory, my py app, and this is just a simple directory, and it is right now blank, nothing is here. All right, so let me put a diagram here so that everyone can follow me. So what we have done, like, we have created a directory. The directory name is my py app. This is the directory name. All right, in this directory what we are going to do, we are going to create a simple code. We are going to write a simple code, okay. This is going to be our application code, and we will name this code as app.py. app.py. Py means it's a Python program, okay. app.py. How to write a Python code? This is not, we are not going to, this is something you can say it's a developer responsibility. You will get a code, okay, and if somebody knows how to write a code, that is good. If somebody doesn't know, that is perfectly fine, okay, because we are here learning Docker, and you will get this code. So this is app.py. Let me create a very simple program. So we'll go here at our machine, we'll say vi app.py, okay. This is a simple code. I'll explain this code in a minute. It's a very simple code, okay. Don't worry about the coding part right now, okay. So this is our code, okay. It uses Flask framework. It is written in Python. It will display this message, hello, this is simple web application. This is a web application, and whenever you connect to this particular application, you will get this message, hello, this is something something, okay. And this application listens on the port number 5000, because an application will run listen on some port. This, in our case, it's a 5000 port. All right, so this is very simple code, not a 100-200 line of code. It's a 3-4 line of a code just to display a message. That's it. Whenever you connect to this application, this is what. So this is our code. Now this code I want to run as a container. What is the next step? The next step is, first step number 1 was code. Code, I can get it, I may write it, but there is a code. Step number 2 is basically Dockerfile, okay. Now try to understand. It's very simple. What is Dockerfile? A text file that will contain all the instruction to run this code in the form of container. That's it. Whenever this container run with this code, it should display this message, okay. This is what we want. So in order to run this code, what are the things that is required? We are going to document in Dockerfile. First statement we have discussed last time, from. From is going to tell me who is, like, what is my base image. Base image is something like, I have given you an analogy that whenever we try to purchase a laptop or something, we generally discuss what is the kind of what is my requirement, right? I am going to take a Mac laptop, Linux laptop, Windows laptop. That depends upon my requirement. So here, because my application is written in Python, so I want to use some base image where Python is already installed, right? That will be better for me. Instead of installing manually, I can say let's take any Python image where Python is already installed. So I will take this image from Docker Hub. So we'll go to Docker Hub. I got a question, who defines which port which application should run? Defined by the application owner. Whatever the port they want to open, wherever they want to run, that is defined by the application owner, okay. Yeah, the coder. We generally don't use the well-known port. We use something for application 8000, 8080, something like that. That is something nobody can guess, okay. So we just keep it like this, okay. If it is a web application, logically it should be listened on port number 80. So what we do, we don't do. I mean, we just take a different port. So let's go to Docker Hub and see, is there any Python image available? Okay, I'll say Python Python. Yeah, there's so many images available with Python, but we will be interested in most of the time this official image. Why? Remember I told you the official image is something maintained by Docker Inc., the company behind Docker. Okay, so we will just check this one and we'll say, let's check this checkbox. Yes, there are now very less images, and one of them is Docker official, Python official image. It says Docker official image, and this batch is also there. Whenever this batch is there, so we just need Python. We don't need Django or all these things. We just need Python, very simple image. So we'll click on this Python image. Okay, when you click on this Python image, so there are so many images already uploaded in Docker Hub. Okay, this is one version, another version, another version, another version, another. There's so many Docker Python images that has been already uploaded by Docker Incorporation. Out of this, which one is good for me? I don't know right now. All right, how could we know that? I can ask my developer, hey, which image, which Python you want me to use? He will tell me like use this particular image, 3.8, 3.14, 3.9, 2.2 is 9. I think no one is using it right now. You can see there are 3.12 Alpine, 3. Something, and if you just want to use only Python, okay, there is Slim image. Slim, the name itself says it only contains Python. That's it. So basically it is an image. It is an image already written by Docker Incorporation that has Python installed inside it. Okay, this Slim image, only Python install. And Slim means the size is like, you know, small. This is not a huge image, it's a simple size, simple image. So I'd say, okay, fine. For me, I know, like, you know, because I'm using this application, 3.8 is okay for me. I can also use 3.14, but 3.8 is okay. So I'll say from this is going to act as a base image. It is something like on your laptop, Windows is already installed, you are installing something on top of it. But this Windows is, I mean, if I'm, no, it's very light, very small. It has only Python installed, no extra software, nothing extra. Remember we discussed about this. I have given you an example. If you want to run WebEx, what are the things that require? Let me go there. Where is that? Somewhere I have explained. Yeah, this one, right? We don't require printer driver, we don't require MS Office, we don't require Teams to be running, we don't require Adobe. I just need WebEx to run, WebEx code plus dependency. This is what we are trying to trying to adopt. We are saying, okay, this is my application written in Python, so I just need Python. So that is why from is acting like this. Then there is something known as work dir. Work dir is basically the command where it tells, like, you know, where we should install setting up your kind of a directory where all your application get installed, all the dependency get installed. It is something like C program files. It is something like C program files. By default in your Windows laptop, everything get installed under C program files /teams, C program files /webex, C program files, maybe your username and something, a default location where everything will get installed. Is it necessary to create a work dir? Not necessary. Is it good practice? Yes, it is a good practice to create a work dir where you will define everything will get installed at this location, where inside the container. When you create a container, in container /app is a directory will get installed and your program will run inside it. If it require anything extra, any dependency, it will also get installed inside this directory. Okay, that's the meaning of work dir. All right, there another command is copy. Copy, as I explained you, it will copy. I mean, copy command syntax is always remain same. You need to define source and you need to define destination. किधर से किधर copy करना है. That's it. You need to identify what is my source, what is my destination. What is the source here? I am mentioning dot. Dot means my current working directory. Remember, we have created a directory here, and whatever inside it, it should copy everything, whether your code, because your code need to be copied also inside container, right? If your code is not inside the container, what will run? So that is what I'm telling. Okay, Okay, create everything whatever inside your current directory to /app in my work dir. Copy code here. Then I want to install something like, I have some requirement for my this code. Every code has some requirement. Okay, in order to run this code, the Flask must, because I'm using Flask framework, so Flask must be installed and everything we need to define. In Python, we define a file that is known as requirement.txt. Requirement.txt is a file where we define all our dependency, all the dependency we define here. In order to run this code, what are my dependency? That again I can check with developer, or I can do my own research, or it's better because your developer is a DevOps team. Developer is your teammate. You can go and ask, hey, can you tell me what are the dependency here? He'll tell you, yeah, you need to create requirement.txt file. Okay, so what I'll do, I'll say, okay, let me create a file vi requirement.txt, and you have couple of dependency like Flask and some other framework. So whatever the dependency this guy is saying, you just create a file here. So what we will do, we'll again go back to our base. Okay, we'll go here. Okay,
I'm audible to you.
हाँ कौन है?
जी हम एनसीसी लिमिटेड से कॉल कर रहे हैं सर, अपार्टमेंट के लिए रिक्वेस्ट आया था।
अरे भैया अभी बाद में कॉल करना है। Alright, so this is, let's go to our file here. We'll go to our, here we'll create vi requirement.txt and we'll put those dependencies. Okay, we'll say okay, fine, these are the dependency required. Okay, first of all, try to understand the logic first, the framework first. Okay, how these things are, why this dependency is required, why not other dependency, we will come to that. First, let's understand the concept. Okay, how these things are connected. Then why and how part we will go a little deeper when we'll repeat it. Okay, so this is my requirement. So there is a code. I have two files. This is my main code, and this mention all the dependency that is required. But that dependency must also get installed inside my container, right? If I want to run this code anywhere, this whatever we have defined in this requirement.txt file, that must be installed. For that instruction we need to put in the Docker file. Okay, install all these dependencies, and for that the command is run. Remember we discussed run command also. Run will execute the command at the build of an image. When you are trying to build an image, it will run this command. So we need to run this command so that it will install the dependency. How? We'll say pip install. Okay, we'll say -r and the requirement.txt, this file. What is pip? Pip is a Python package manager. Just like apt is a package manager for Ubuntu, yum is the package manager for Red Hat, chocolatey is the package manager for Windows, brew is the package manager for Mac. This is package manager for Python. If you want to install anything in Python, you can use pip. Look, just try to understand. We took an image. Oops, sorry, this diagram sometimes start dancing. Okay, we took an image. I don't know why it is dancing, but yeah, this is an image where Python is already installed. Okay, we created a directory on top of it with /app name, right? Inside the app, we have copied this particular code, right? This is what the instruction is, right? Now we are saying there is a requirement file also inside this, because we copied everything. Copy dot means whatever is in the directory, copy everything inside here. So everything is here. Now we are saying whatever mentioned in requirement.txt, please install it using pip command. So what is mentioned inside the install Flask, install this dependency. So we are good. Okay, so all the dependency will get installed when you run a container. Then our application listens on port number 5000. We need to expose the port 5000. We'll say expose 5000. This will open a port in my container. Now everything is done. Python installed, yes, installed. My code got copied, yes, it got copied. Are the dependency installed? Yes, it's installed. Is the port got exposed? Yes, the port got exposed. But what is the main thing? Whenever container gets started, it should run my code, right? My code should be get running. It is something like startup script. Whenever you boot your laptop, some of the programs will automatically get started, right? You may have seen it. You have not started this program, but program will get started. Why? Because when computer boots, it reads the startup file. Okay, whatever you mention in the startup file, all the programs will automatically get started. It is similarly, all these things are fine, but ultimately I want to run this code. Ultimately, I want to run this code, right? I want to run this code, right? Yes, this one. So I need to tell my container, whenever you get started, please run this code. And that command for this is cmd. There's one more command, we'll discuss about it. That is entry point. What is the difference between entry point and cmd? We'll discuss about it. There is a slight difference, but let's use cmd right now. I'll say you run this command. Which command? I'll say run Python, okay, comma, and the program name is app.py. Okay, why Python? Have you run any time a Python program? Say for example, I have written a Python program. How to run a Python program? In order to run a Python program, you have to go to the prompt and write Python and your program name. That's it. If Python is installed, say for example, if I go to the CMD of my laptop, okay, if I go to my desktop of this, let me open CMD, command prompt of this laptop. Okay, this is command prompt of my laptop. If I have a Python program running here, okay, run a Python program. First requirement is on my laptop, Python must be installed. Then how to run a program? Python and the name of the program. This is exactly what we are doing. We are telling run this command with Python app.py. And where is app.py? App.py in my /app folder. So all the instructions are given correctly. This is what the Docker file is. You need to tell all the instruction how to. Let's go and read the definition. What is Dockerfile? It's a Dockerfile is a simple text file that contains all the instruction. What are instruction? From is an instruction, work dir is an instruction, copy is an instruction, run is an instruction, expose is an instruction, cmd is an instruction. Okay, run set of instructions, so collection of instruction. Telling what? Telling Docker how to build an image. So this file will create an image. That image will have Python, an app directory. Inside an app directory, my code and the requirement will get copied. Requirement will get installed and it will get exposed on 5000 port. Whenever you run this container, this code will start. And what is this code? Nothing but my main code, my main program. Are you folks able to connect it? Is it making sense now? Little bit. Alright, so let's create a Docker file here. The way we have created, we'll go here. Let's go to our computer. Where is my putty? Where is my putty? Yeah, this is right. So this is my directory. We'll create vi Dockerfile. Docker, yes, spelling is correct, and we will paste our Docker file, whatever we have created. All the codes, everything is available in my GitHub. You can use it. All right, so ls, what are the things here? We have Docker file, we have app file, we have requirement.txt. Let me go to my diagram. So we have app.py, yes, we have. Okay, what else we have? We have Docker file. What else we have? We have and requirement.txt, right? All these things are inside my directory. I'll just mention rec.txt. It's a full spelling is requirement.txt because the name will be so long it will go outside the body. Okay, so all these three files are here. Yes, it's there. Using all these three files, whatever mentioned in Docker file, we will create an image now. Okay, what we will do? We will create an image. That image will get created and stored at my local desktop. Okay, this image will create Docker image. How to create an image from a Docker file? the command is docker build. Okay, if I show you, I mean, we already downloaded all those man pages, right? The hint of all the docker commands. Where is that? Yeah, this, right? Can you see build somewhere? Build kill port. I think it must be at the top, because builder plugin search push exe. I'm not able to see it. Somebody identify where is build. Let me copy. Line number 330. 229. Yeah, build. Sorry, yeah, build an image from a Docker file, right? The command is build an image from a Docker file. The command is build. Okay, so we got the information. See, I'm not telling you anything directly. I'm telling you how to search and build your own concept. Okay, I can give you command directly. Here is the command docker build, but go to man pages, read it. I need to build a file image from a file. Okay, this guy looks perfect to me. Okay, the command is build. All right, so this is the way we do research. So command will be, I need to go to my prompt. Here I need to type docker build. Okay, docker build, that is fine. Okay, docker build is fine, but when we build, okay, before that, let me go to my putty, and here let me show you docker images. In docker images, there is something known as repository, there is something known as tag, there is something known as image ID, there is something known as created and size. So these are the field of a docker image. Okay, so what you need to do whenever you want to build it, okay, you need to tag it. You need to say -t for tag that image. Okay, and you can give a repository name :tag name, something like this. You can say something like docker run, or let me first build it very simple. I'll tag it with, say, for example, simple web -app. This is my tag. Okay, and this I'm running a docker build command in the same directory, so I'll mention as a dot here. The dot here is your build context. Where is your docker file, where all the dependencies, where is your code, everything should be at this particular location, because in our case it's the current directory, we are sitting inside that directory, so that is why I'm putting a dot here. Okay, so we can run this command. In our case, there is no image right now, right? We are sitting here, we want to build an image, that is fine. The command is what? Docker build -t and some tag name. This is what the syntax is. Perfect. All right, now let's go ahead and run this command. I got some message, that is fine. You can see this is step 1 of 6, something it is doing something. All right, don't worry, I'll tell you is line by line of this particular thing. Okay, I'll explain everything. Because I need to copy all these things. What I'll do, I'll just copy this command from here till the bottom. I got something, image got build or something, right? We got this message as well. Let me first paste this in your notepad, because I need to explain you what happened here. And okay, and I will explain you everything in detail. Don't worry. First, let's see what it says. Successfully built ACE something. All right. So let me run docker images. Have you got our image? Yes, simple web app, and this ACE is the image ID we got, but also there is a Python slim got downloaded. Why it got downloaded? Because that's our base image. That is necessary, right? We mentioned this Python slim image 3.8 in our Docker file, isn't it? Right? We mentioned that this is going to be the base image. On top of this base image, you do this, and my image got created with simple web app. Do we have our own application, our own our own image with our own code? Requirement is there is syntax in Linux, Python Sunil, where we define all the dependency of my code. Requirement.txt. Okay, where we say, we define the dependency. Yeah, no problem. Okay, so we have our image. Yes, we do have our images. How to create a container out of it? Just docker run, right? We can say docker run. So what we'll do, we'll say, okay, let me create a container, docker run. Okay, there is one thing I'll use -p. Okay, and we'll say what port I should use at the base image. Let's say use 80, just to make sure that 80 is there, and I'll match with the file. Whatever I'm doing here, don't worry, I'll explain you. This concept I will explain you networking. Okay, but I'm doing something known as port binding. And what is the image name? Image name is this. I will use my image. Okay, that's it, right? What is this? Don't worry, but 5000 is, I'm telling that my container listens, my application listens on the port number 5000. All right. What is 80? I'm mapping the base, my base machine port, but in networking it will become crystal clear whatever I'm doing it here. When I'll explain the networking concept in next few minutes, this will become clear. But let's focus on the image, container build part. Docker run is a command to build an image and build a container using this particular image. So let's go ahead and run this command. Let's go here, go to our, and we'll clear the screen. We'll say docker ps, anything running? Nothing is running. Docker ps -a, is any stop container? No, there is no stop container. Let me put my command, docker run enter. Okay, my screen got logged. Yes, because the problem is I'm not using the -d, right? So whenever you are not running as a background process, your current session will get logged. Container is running. If you press Ctrl+C or something, it will kill your container. So how to verify that container is running or not? What I will do, I'll just take a duplicate session. Okay, I'll say let's log in on a different session and give your password, become root, because we are running everything from as a root. If I clear that terminal and if I do docker ps, can you see that it is running? Let me maximize the screen and rerun this command. Can you see that a container is running with this container ID? Name is this, image name is this, and there is some container funny name sad Tesla, right? Because we have not given any name, but it is running from last 46 seconds. Yes, this is my container that is running. Okay, 474 cc. So this is something is running under my screen. And how to verify that my application is running or not? So what we will do, we will take the IP address of this machine. Okay, I don't know the, I know the IP, right? Because we have connected to this. So we have copied the IP address somewhere here. This is our main machine, base machine IP address. Yeah, localhost is also good, but let's run on because it's exposed to the internet. So we'll say this and try to run it. Can you see that I'm getting an output? Hello, this is simple web application. Even you can put this IP, you will get this response. Hello, this is a simple web application. Isn't it our code output? What was our code output? Our code says, hello, this is a simple web application. All right. So what happens here? Okay, what happens here? Basically, if you go here with my diagram, I'll explain you everything now one more time. This is my laptop, or this is my Linux machine. This is my Linux machine where we have Docker already installed, right? We have installed Docker. This Linux machine, we have installed Docker. After that, what we did, we created an image. We have created a file directory inside it where we have put all our code, and this is my app, right? Here we have couple of files, Dockerfile, app code, requirement.txt, everything, right? Okay, I'm just copying 3 files here so that I'm not naming it because we all know all the 3 files are here, right? After that, we created an image out of it. That image is locally stores here, okay, on my desktop only right now, on this Linux machine only. With this image, we have created a container, and the container started running on top of my machine like this. This is my container is running here. Simple, what is that? Simple web. This is not the container name. Container name is something sad Tesla, right? Whatever the name. Okay, I don't want to put sad or something. It's just like some container is running. All right. Now I am sitting at my laptop here. Okay, this is my laptop. All right. I want to connect an application that is running inside the container. Okay, I want to connect to this application, right? But container doesn't have the IP, the public IP. How the traffic will flow? Okay, I'll just give you a very high level. We will talk in detail about networking. But my application is running inside this base machine or inside the container. My application is running here. Container. My app is running here. I want to connect to my app. So the traffic will flow. First you need to go to the base machine. From base machine, there is something in between that we'll discuss in networking in a minute. Okay, the traffic will go to this, from here to here, something like this. Arrow is not, I can drag it like this. Okay, so first it will go to here, and then from here it will go to the container. That is why we map the port. We mentioned that -p : we have mentioned something like -p 80 mapped with 5000. So 80 is port list. We are listening like, port is 80 is something like the port that is on top of the base machine, and whenever any traffic is coming on port 80, it will go to the container. But don't worry, I will explain this part in much more detail in networking. What is this, or how the traffic flows? I will explain you each and everything. But how we connected, the app is running here. We cannot connect directly. We are not connecting directly. The traffic is going something like this. Okay, the traffic is first going to your base machine. From base machine, it is going to something in between, that is a bridge, and then it will go to your application. Then we are able to see the output of my application. All right. But the point here is this diagram is clear now? Is this concept is clear? Code, Dockerfile, Docker image, container. Good. But the point here is, when we created this image, image is available locally right now. But generally what we do, we push our image to Docker Hub or any private repository that we are using. Okay. So what we will learn now, the image is available locally, but say for example, you want to also use this image. You are my teammate. How could I share this Docker image to you? Like what we generally do when we build an image, we upload this image to Docker Hub using Docker push command. We'll upload this image here. Okay. We'll upload this image here and we'll run Docker push, and the image will get uploaded here, so that anyone can go and download this image to their laptop or their machine where they want to run this container. Okay, and they can download this image using Docker pull command or Docker pull command. Even if you run Docker run, it automatically pull will run at the backend. And then remember, when we run the Docker pull command, first it download the image. So actually Docker pull is inbuilt in the Docker run. But if you want, if you just want to download image, you can run Docker pull. So what we will do, we will stop our container, and we'll try to replicate this scenario. Why we run this container? We just want to make sure that container is running, my code is running, everything is good. So we have an image here. So what we'll do, we'll say Docker stop and set Tesla. I think I have taken a session, right? My session is there. So it will take some time. Yeah, it got stopped. So if I do Docker ps, nothing is running. Docker ps -a, Container is there. Let me remove this container, docker rm, and the container id, we can give container id or name, got deleted. The container got deleted. If I do docker ps-a, nothing is here. If I say docker images, yes, image is here, but I want to upload this image to my Docker repository. Okay, so what we will do, we'll go to Docker Hub. Okay, we'll stop this. We'll go to Docker Hub, and first we will log in. We'll sign in. If you have not created your Docker image, Docker Hub account, you can create it. It's very simple. Just like you have created a GitHub account, you need to go to sign up and create your account. Okay, once you create your account, you can give your, you have a discover DevOps is my user ID, and similarly you will get also your user ID. So this is my all my repositories. Just like in GitHub we have so many repository, here also we have repository. Okay, and there are so many repository. But the point here is, most of the repository you will see that all are public, and there is only one private repository. This one, right? This one is a private repository. So in your free account, when you are creating Docker Hub account, by default it's a free account. You can create one private and many public repository. Private repository is something like it's protected by your username and password. Somebody have your username and password can access it. If somebody doesn't have your username and password, they can't access it. Okay, so how to create a repository? It's very simple. You can just click here. Let me do one thing first. Let me delete this private repository, or let me where is my private? Yeah, this one. Let's do one thing. Let's create from scratch. So we'll go to repository. We'll click on here, create repository. Okay, create repository. Click create repository. You can give repository name. I can say repository name is August 2025. You can say this is for test. You want to create public or private, because I have already have a private repository, so this time I cannot create one more private because it's a free account, but I can create as many as public repositories. I'm saying yes, create a public repository. Okay, just you need to click on private, it will create private. I'm creating here, and pushing images command, you can just you can just copy it, because this is something we will use. I will explain it. So again, let me put it here. Just I'm copying this command because I need to explain you the syntax. But after that, what you need to do, just click on create. So you'll see that a repository get created. But what is the naming syntax of repository? The repository naming syntax is your user ID / your repository name. Can you see that? Your user ID / your repository name. Okay. It is not only repository name, it's your user ID / your repository name. Just this is a syntax that we need to follow. Why? Because you can also create a repository name with the same name, August 2025. How Docker will differentiate? With your user ID. So the full path of your repository is username / repository name. That you need to remember. Okay. What we can do is, we can go here with our desktop notepad. So path is user name / repo name. Right, this is the path. Now if you want to tag, if you want to push any repository to this, any image to this repository, the command, it says first you need to tag your local image with this new image. Right now our image has a, this is the repository name and this is the tag. Okay, so what is my repository name? My repository name is this. Okay, so first I need to rename my image, retag my image. How to do this? Docker tag is the command. Okay, we'll say docker tag. What is the local name? Local name is this, repository name. Okay, colon tag name, and the tag is by default is latest. If you don't put anything, it will come as a latest. Okay, I need to retag it. I'll say this is my repository name. Okay, colon tag name. I'll say my application code version v100. This is my 100th version of my code. Are you getting it why I am doing this? Because Docker should understand that this is your user ID. Under this user ID, you want to push this image under this repository with this particular tag. Okay, so that is why we need to retag it. So what we will do, we'll go and run this command. Docker images. Okay, we'll run this command. Now if I go and run this command docker images again, can you see that the image ID is same? This is same as this. This is the same image, but the tagging got changed. This is my repo name and this is a tag. And now we need to upload this image. If it is a private repository, you have to first log in to you with your Docker Hub account. How to do this? Docker login. Once you run this command docker login, it will ask you what is your username. Sign in credential. Okay, Docker. Okay, it is waiting for me like this. So what I will do, the command got changed. What we need to docker login -u. What is my username? My username is this, right? I'll just paste my username. It will ask me the password. You need to give password. So it says yes, login succeed, right? So login is good. Now I need to push this image to Docker Hub. So what we will do, we'll go and run. What is the command? Again, we have downloaded the command docker push and your image name. So what we'll do, we'll say, okay, I need to push this image. We'll say docker push, but you have to give the full path. You want to push like this, repository name and the tag name. Okay, so we'll copy this command and we'll push it. Before that, let me go to Docker Hub. Can you see that there is no tag? It says image, right? There is no image, right? So we'll go ahead and push this command, push this image. You can say it is now preparing. It is pushing, not pulling. It is pushing. Can you see that? Push, push, push. It is pushing everything. Wait for a minute, it will get uploaded. It says yes, the SHA code is this, size is 1783, fine. Let's go and see there. Refresh this page. Can you see that image is here now, v100? So this is what the syntax I'm telling you. This is my repository. Under this repository, this is the image actually. That image we see as a tag name. Okay. So what is the full path of the image? The full path of the image is this/this colon this. Can you see that? Docker push. This is the username. This is your image name colon tag name. This syntax you need to remember. Whenever you want to push to Docker image, Docker Hub, this is the syntax that you need to follow. Okay. What is the syntax? This is in our case, but general syntax is docker push, okay, your username slash repo name colon tag. Are you folks with me? Yes, we can do this, Shrita. Image will be also there. Push is like image is still there. Okay, so image, we have uploaded the image to Docker Hub. Yes, we have uploaded the image to Docker Hub. What we will do, we'll try to replicate this scenario. Which scenario? We will assume that, we'll go to our diagram. We'll assume that now we are sitting here. This is my Linux machine. Okay. We will run container using this image uploaded in Docker Hub. So for that, again, what I will do, I will remove everything from my system. So I'll say docker system prune -- all. Don't run this command just for fun, okay? Your life will become fun after that. So everything got deleted. Yes, make sure that nothing is here. Docker images, no image. Yes. Docker ps, no containers, running container. Docker ps -a, no stopped container. So my system is a brand new system with no images, no container. It's something like I have just installed Docker. Now I want to run a container using my image. How to run it? If you want to know, you can just go to Docker Hub and click this your version image. It will also tell you how to run this container. Okay, here you can see this is the image name. This is the image path. You can just copy this image path. Okay. And remember also you can mention this SHA hash code when the image got uploaded. You can just match it. Sometimes we just to make sure that the correct image got downloaded. And this is our Docker file, and I will explain you all these things. Now what we'll do, we'll just copy the path of the image. This is my image, and I will say Docker run, and please run excuse me, run this command at your desktop as well. If you have Docker already installed, Docker run this one. Okay, so we'll say Docker run this. But what we will do, we'll also give some name this time. We'll say -n, okay, hyphen name, right? Remember last time we have used hyphen name. I'll say my app. Okay, we'll say -p 80:5000, and we will run also in at the background, right? So we'll say Docker run -d. Command looks okay. Am I making any mistake? I think it's okay, right? Docker run -d name p. It looks good. Let me run it. It says unable to find the image. Obviously, image is not available locally, so it's downloading from my repository, not anyone's repository. This is my repository. It says something happened. Okay, our prompt didn't get logged because we have used -d to run as a background process. Remember, I told you that I'll explain what is -d, right? So -d is, if you don't use -d, your prompt will get logged. So we use -d. So if you say Docker ps, yes, there is a container running with my app, all right, and this is what the name we have given, my app something, right? Where is the command? My app, right? That is fine. And what else? Yeah, it is using this particular image. This is my image. Yes, this is my image, and yes, this looks okay to me. Let's go and try to test our application. We'll copy the public IP address one more time. Where is my public IP address? This is my address. We'll go to our browser. Yes, I'm getting the output. Cool, right? Are you getting it? This process is now clear. Image creation, upload an image, run and upload to your Docker repository, download that image, run the container using your image. So this time this code is running here in the form of container. This is what the whole purpose of, right? We started from here only. We mentioned that we want to run this code. Remember, we want to run this app, must be running. We are running this app not in physical machine, bare metal machine, not as a virtual machine. We are running this app in the form of container. So we have containerized our application. My application is running, yes, in the form of container. As a container it is running, right? This is my code is now running as a container here, because we have created Dockerfile, and from Dockerfile we have created image, and we have uploaded this image. I mean, if I need to come back here, we are not using Nginx image, we are using our own image, right? We are using our image to run my app. Now I will stop here and take your questions. Okay.